I'm Adam from RFOXiA, from our real lab. Today we're answering one specific question: what does it actually mean to own your wireless network outright with no monthly cost, no ISP, and no infrastructure you don't control? The conventional mental model for wireless communication goes roughly like this. You have a device, the device connects to a tower, the tower connects to infrastructure, the infrastructure connects to another tower, and eventually a signal arrives somewhere useful. At every step in that chain, someone owns something you don't. Someone is billing someone else. And if any link in that chain fails, breaks, or decides to charge more, your application stops working. That is the model the entire commercial wireless industry was built around. And it is a reasonable model if you are a consumer making phone calls. It is a deeply unreasonable model if you are an engineer who wants to deploy a sensor array in a field, or control a drone beyond line of sight, or build a mesh communication network for a field team that does not have cell coverage. What I built at RFOXiA is different in one specific and important way: the network belongs to you. The Multinav Pro Plus BLE module operates on standard, unlicensed Bluetooth spectrum. It does not require a SIM card, it does not require a cellular plan, it does not require a Wi-Fi router, a LoRa gateway, a Helium node, or any piece of infrastructure you do not personally own. When you pair two modules, you have created a private point-to-point wireless link. That link operates without permission from anyone. It costs nothing per month to run. It does not depend on whether a tower near your deployment site is functioning correctly. The range numbers are where the physics becomes interesting. In a standard Bluetooth configuration, the limiting factor is receiver sensitivity. Most commodity BLE modules achieve 80 to 100 meters in good conditions. They were designed for consumer electronics, earbuds, fitness trackers, smart locks. The question the entire industry was answering was: how do we make this cheap and adequate for indoor personal area networking? That is a fine question. It is just not the question I needed to answer. The question I needed to answer was: how do we extend Bluetooth range to the point where it becomes genuinely useful for outdoor deployment, drone control, and long-range IoT, without crossing into licensed spectrum, without adding cellular modems, and without a price tag that excludes independent builders? The answer turned out to involve the receiver rather than the transmitter. Most attempts at extended range focus on amplification, push more power out, shout louder. The Multinav Pro Plus takes the opposite approach. The chip at the center of this design achieves -104 dBm receiver sensitivity. That means it can detect an extraordinarily weak incoming signal, far weaker than anything a commodity BLE chip would recognize as valid. You are not shouting louder, you are listening better. Combine that sensitivity with an optimized RF front end and a high gain antenna, and the physics gives you numbers that sound implausible until you understand the signal chain. Ground to ground, meaning one module paired to a phone and a second module paired to another phone, both users standing on Earth. The practical range is around 5 kilometers. Man to drone, meaning one module on the ground and one elevated on an airborne platform, with the ground reflections that degrade signal eliminated on one side, range extends to 15 or 20 kilometers. Drone to drone, where both platforms are elevated and ground reflections are eliminated on both sides, range reaches 50 kilometers. These are not theoretical maximums. They reflect the actual physics of free space path loss combined with this specific receiver sensitivity figure. Now, what that range means practically: two modules operating in this configuration create a fully private wireless network. Not private in the marketing sense of the word. Private in the literal sense. The signal travels directly from one module to the other, unmediated by any infrastructure you did not deploy. There is no cloud service logging your packets. There is no API rate limit. There is no service agreement that can be changed unilaterally. There is no monthly billing event that, if it fails to process, takes your deployment offline. The data rate is 2 megabits per second. That is sufficient for real-time telemetry, GPS position streaming, sensor data aggregation, drone control inputs, and the BLE chat functionality built into the RFOXiA Connect app, which allows direct text and voice communication between paired module users over this same link, entirely without internet connectivity. The mission statement I have attached to this product is precise. The Multinav Pro Plus BLE module lets you build and own a private long-range wireless network that costs nothing to operate after purchase. That sentence is technically accurate. The purchase cost is $59 for 2 units. The operating cost after that is $0. There is no asterisk on that figure, no hidden infrastructure dependency, no tier of service that restricts what you can do with the hardware you bought. This matters most in 3 scenarios. First, remote deployments where cellular or Wi-Fi coverage does not exist or cannot be trusted. Second, applications where communication privacy is a requirement rather than a preference. Third, builders who are tired of building systems that work correctly until a third-party service decides to change its terms, raise its prices, or simply stop operating. The FCC certification on this module is worth noting in this context as well. This is not a gray market part operating outside regulatory boundaries. It is a certified device operating legally on unlicensed spectrum, which means there is no license application to file, no regulatory complexity to navigate, and no geographical restriction on deployment within the United States. It ships. You deploy it, it works. That is the entire process. The conventional solution to long-range wireless, which is to say adding cellular, LoRa with a cloud gateway or licensed spectrum hardware, adds cost complexity. So that is the network, the range, the receiver sensitivity, the zero operating cost. Now let me show you the actual hardware that delivers it. This is the headline capability. Two of these modules, nothing else, establish a private wireless link up to 50 kilometers. No towers involved, no subscriptions, no infrastructure you did not deploy yourself. That is the entire premise of owning your network. 2 megabits per second over that same private link. This is not a telemetry only connection. It is fast enough for drone control inputs, real-time GPS position streaming sensor data, and the BLE chat voice and text functionality all running simultaneously without contention. The STM32WB07 at the core of this module is the reason the receiver sensitivity reaches minus 104 dBm. It manages the BLE stack and your user application on the same die, which means no external processor bottleneck and no added latency between the RF front end and the application layer. 57 by 47 millimeters. The antenna extends to 140 millimeters and is integrated. No external antenna required. No UFL connector to manage. No additional hardware to source or break in the field. This is a complete RF system in a form factor smaller than a business card. The 4 connector interfaces, GNSS, sensors, motor and battery management and programming, are how this module becomes a platform rather than a standalone part. Connect the GNSS module for precise positioning. Connect the sensors module for environmental data. Every interface was designed to eliminate the custom wiring work that normally consumes build time. The RFOXiA Connect app turns your phone into a ground station. PS5 style controller for drone and robot inputs, live map with real-time position from the GNSS module, and live sensor data, all over the private BLE link, all without internet. The app is the user interface for the network you built. BLE Chat uses the same private link, the same 5 to 20 kilometer range, to carry direct text and voice between paired module users. No cellular, no internet, no relay servers. This is direct device-to-device communication operating on spectrum you are legally permitted to use without a license. Full open source access and SWD programmability means the behavior of this module is yours to define. The firmware is not a locked binary. Every output, every protocol decision, every integration is customizable. The hardware sets the physical limits. The application layer belongs to you. The integrated RTC crystal provides precise timing for synchronization across distributed nodes. In a multi-module deployment, where several sensor nodes are streaming to a central unit, timing accuracy determines data integrity. This is the component that makes time-stamped distributed sensing reliable rather than approximate. The question I kept asking while designing this module was whether those dependencies were solving a real constraint or just inheriting the assumptions of an industry built around a different use case. The answer most of the time was the latter. The industry built infrastructure-dependent wireless because it was building consumer products for consumers who were already connected to infrastructure. Independent builders are not that user. Independent builders need ownership, range, and zero operating cost. That gap is exactly what this module was built to close.